Hello, IM2T. I am so sorry that I'm out again. I promise I would be there if I could. Just things, yeah, are a bit crazy. But hopefully this video helps you guys, and you can always email me or Gchat me in the middle of this if you have any questions. So this is the last lesson in Unit 4. It's the last thing you're going to be learning this semester. So this invitation says to draw and label a prism or cylinder that has a base congruent to the solids and a height equal to the solids. So if we want to draw a prism would just look like this. I am not good at drawing. Okay, that's supposed to be a prism. Hopefully you can see that. And so the base has to be congruent. Okay, so, and then the height has to be congruent as well. So that would be, wow, that is one ugly, well, that is one ugly prism. Something like that. That's a little bit better. All right, and then for the second one, we want to draw a cylinder with the same base area. So it has to have the same base, and the height will be 10. All right, so that's it for invitation 1. Pretty straightforward. It doesn't say anything about volume being the same. Evaluate the volume of each solid mentally. So volume is always going to be, for a prism and cylinder, it's the area of base times the height. So the area of base for this first one is 24 over 2, which is 12, times 10, it's 120. Because the area of the base is 12, and then the height is 10. For the cylinder, we know that it's going to be pi r squared times the height. So this is going to be 25 pi times 8, which is going to be 200 pi. All right, and then for the next one, the volume of a cone, you'll learn later on in this lesson, actually, the volume of a cone is 1/3 area of base times the height. So it's 1/3 pi r is 5, squared times the height. So that's going to be 50 pi altogether. And then the last one, same thing, volume is area of base times height divided by 3. So it's 1/3 12 times 6. So that's going to be 24 units. All right, and now let's move on to the notes for the day. All right, so the last lesson, I can explain why the volume formula for pyramids and cones is 1/3 area of base times height. I can calculate volumes of pyramids and cones. I can work backwards given a volume to find the dimensions, and I can use Pythagorean theorem to solve various problems. All right, so pause the video now and you guys try activity number 1. Okay, each solid in the image has a height of 6 units. The area of each solid's base, so the area of the base is going to be 10. And a cross section has been created, dilating with a scale factor of 0.5. Calculate the area of each of the 3 cross sections. So the area of all of them is going to be the same. They all have the same height. The area of the base is the same. So the volume will be the same. So if we want to find the area, okay, remember what we did before. So new area is old area times k squared. So the old area is 10, and you're multiplying it by 1/2 squared, which is 1/4. So it's 10/4, which is 2.5. Suppose a new cross-section was created in each solid, all at the same height using some scale factor k. how would the area of these three how the cross sections compare? They would all be the same. So the new area is always going to be the old area, which is 10, multiplied by k squared. So all three will be the exact same. What does this information about cross sections tell you about the volumes of the three solids? We learned last lesson that the volumes will be the same for all three solids. Because the area of each cross section is the same, we know that the volume will be the same. All right. Calculate the volume of each of the solids. So we know that they're going to be the same. So the volume is going to be 1 over 3 area of base times height, which is 1 over 3 times 10 times 6, which is 20 cubic units. All right, so that's basically it. You're just finding the volumes and applying the volume formula, which is 1 over 3 area of base times the height. Okay, you guys pause now and try activity number 2, especially that regular hexagon for part D. That's particularly difficult, so make sure you try that. All right, so the first one, the volume is 1 over 3 because it's a pyramid, area of base times the height. I should say the takeaway here. For pyramids and cones, volume is 1 over 3 base times height. All right, so this is going to be 1 over 3 times 4 times 6, which is going to be 8 cubic feet. The next one is going to be 1 over 3 pi r squared times the height. So that's going to be 4 over 3 pi times 4.2. And if you plug that into your calculator, you're going to get roughly 17.6 centimeters cubed. This is feet cubed. The next one, area of the base, it's 1/2 times 3 times 4, which is 6. So it's 1/2 times 3 times 7, which is going to give you a total of 14 kilometers cubed. All right, now for D, the height is 12 centimeters. The area of the base is 32 centimeters squared. So we know that the volume will be 1 over 3 area of base times the height. So it's 1 over 3 times 32 times 12, which is going to be 128 inches cubed, or centimeters cubed, sorry. All right, part 2, a particular cone has a radius of r and the height of h. So let's draw a cone. The radius is r, the height is h. Write an expression for the volume of this cone in terms of r and h. So volume is equal to 1 over 3 pi r squared times height. What is the height of a cone whose volume is 16 pi? So the volume is 16 pi. And the radius is 3. So 3 squared times height. So what you're looking to find is h. So if you do that, cancel out pi. So you're going to get 16 equals 1 over 3 times 9h. So h will be 16 over 3 units when you divide 16 by 3. What is the radius of a cone whose volume is 16 pi cubic units? So if the volume is 16 pi, let's just write in 16 pi. It's 1 over 3 pi r squared times 3. 3 and 3 cancel. So you get 16 pi equals pi r squared, so cancel out the pi's. So 16 equals r squared, square root both sides. So r is plus or minus 4, but in this case, it can only be 4 because radius can't be negative. So your final answer is 4. All right, and you can try the Are You Ready for Mores if you want. There's 3 of them there. Otherwise, let's move on to activity 3. It's the last one of the semester. So pause the video now and you can try it. Okay, so for this one, answer the questions for each of the 2 solids. Which measurement that you need to calculate the volume isn't given? So for the first one, we need to know pi r squared times the height is 7. So what we don't know is the radius for part A. For part B, what we don't know is the height. We know the area of the base, but we don't know the height. The height is missing. So for the second one, how can you find the volume, or how can you find the value of the missing measurement? For A, you can use Pythagorean theorem. For B, you can use SOHCAHTOA to find the height. What volume formula applies? So for the cone, volume is 1/3 area of base times height. For the prism, it's area of base times height. Calculate the volume of the solid. So for the first one, we need to find the radius. If this is 7 and this is 8, use Pythagorean theorem. So this is r. So r squared plus 7 squared is 8 squared. So r squared is 64 minus 49, which is 15. So the radius is root 15. So plug that into your formula. So it's volume equals 1/3 pi r squared, so root 15 squared times 7. So that's going to give you 35 pi altogether when you simplify it, units cubed. And then for the second one, we know that the formula is area of base times the height. So it's 7.5 times 4.5. That's the area of the base, but what we're missing is the height. So to find the height, let's call this h. We know that tan 65 degrees is h/3. Tan is opposite over adjacent. So height is 3 tan 65 degrees. Now, I wouldn't plug that into the calculator yet. What I would do is plug this in all together. We know volume is 7.5 times 4.5 times 3 tan 65. So plug this in once all together. You'll get a total of 217.1 meters cubed. All right, moving on to question 2. Why don't you guys try it now on your own? All right, for this one, we have a triangular prism. The volume is the area of the base. So the area of the base times the height. Okay, so we know that the height is 31 centimeters. That's given to us. We have a triangle. This here is 48. This is 73. So what's missing is this side right here. I'll call it x. So you need to find x, and then you can solve for volume. So we know that x squared plus 48 squared equals 73 squared. So x is, if we subtract 73 squared minus 48 squared, and then take the square root of it, that will give you x. Okay, so the volume will be 73 squared minus 48 squared, and the square root of that, times 48. Okay, so multiply by 1/2 because it's a triangle. So the area of base is 1/2 base times height. Multiply that by 31. When you do that, you're going to get an answer of 40,920 centimeters cubed is your final answer. Okay, for this last one, we know volume is 1 over 3 pi r squared times h. Okay, so we don't know the radius, but we do know this diagonal, but we don't know the height either. So we need to find the radius and we need to find the height. So in order to do that, let's do sine first. So sine 30 degrees is going to be h over 10. So h is 10 sine 30. Okay? And then to find r, we're going to do cosine 30 is the radius over 10. So radius is 10 cosine 30. So now we can plug this in and solve for the volume. So it's 1 over 3 pi. The radius is 10 cosine 30. And then square it, multiplied by 10 sine 30. If you plug all that into your calculator, you're going to get an answer of 392.7 inches cubed as your final answer. Okay, last problem. For a sphere with radius r, its volume is 4 over 3 pi r cubed, and surface area is 4 pi r squared. So the formulas are given. You don't have to memorize these two. Okay, but they're given here. Here is the half sphere bowl pressed out of a piece of sheet metal with area 1 square foot. What is the volume of the bowl? So the volume of a sphere is 4 over 3 pi r cubed. But this one, because it's half of it, we know that it's going to be 4 over 3 pi r cubed divided by 2. So it's 4 over 6 pi r cubed. Okay, that's the volume of this bowl. The area, okay, so the surface area of a sphere is 4 pi r squared. The surface area of this bowl is going to be 4 pi r squared divided by 2. So it's 2 pi r squared. If we know that that area is 1, then that means that 1 is equal to pi r, 1 is equal to 2 pi r squared. So that means that 1 over 2 pi equals r squared. So r will be the square root of 1 over 2 pi. Now what we need to do is we need to plug that in here. So volume is 4 over 6 pi. And then we have the square root of 1 over 2 pi to the power of 3. And when you do that, you're going to get an answer of 0.133 feet cubed. All right, go ahead and start on your Delta math activity. Okay, make sure you do that. There's only 2 or 3 questions from each section. And then after that, you can start on the homework. Review period next class. Test is on Friday. All right. Have a good one.